Buonasera, ci siamo. Salve, grande. Sono sempre molto felice di essere qua con voi. Grazie. Veramente grazie di cuore. Mi scuso per questo ritardo, non è nello stile di MtMG Guru, iniziamo puntuali, abbiamo superato il quarto d'ora accademico, adesso non vi faccio perdere altro tempo, siamo in attesa che arrivi Cristina Tajani, che è l'assessore del Comune di Milano, che ha promesso che viene e verrà, sono sicura. E comunque era anche per dare il posto alle persone per accomodarsi, quindi se c'è ancora qualcuno che è rimasto in piedi eccetera, forse un posto o due qui davanti ci sono e siete benvenuti. Allora, prima cosa veramente grazie a voi, una giornata di sole dopo un po' di pioggia come c'è stata in questi giorni, di sbalzi di temperatura che vengono e ci fa sempre un grande piacere. Ci tengo per le persone nuove che conoscono, che entrano in contatto oggi con MtMG Guru, di ricordare due cose. Intanto farei un bellissimo applauso caloroso a Lining Yao, che è qui con noi e che dopo salirà con noi, sarà lei l'ospite di questa sera. L'ho vista lì, ma adesso eccola lì, Lining, eccola lì con noi. E quindi dovete sapere che è la prima volta che viene in Italia, non solo a Milano, in Italia, quindi l'ascolteremo e poi la coccoleremo. Poi vorrei ringraziare, diciamo, tutta una serie di... Voi capite che MtMG Guru si regge veramente con la partecipazione, l'incoraggiamento delle persone, di amici che fanno anche la loro parte diffondendo. Mi viene in mente Massimo Ferrari, mi viene in mente Antonio Mancinelli, che è un vice redattore importante del mondo della moda, che ha detto no, ma questa cosa alla moda deve interessare, quindi dobbiamo darci tutti da fare. L'innovazione riguarda tutti i settori, perché la moda, perché il design, ma l'abbiamo già visti questi cambiamenti in atto. Quindi sono tutti amici che si attivano, amici e anche volontari e creativi, come i ragazzi, i fotografi della scuola Cavendish, che vedrete giro con la macchina fotografica, volontari come social reporters, che sono la nostra anima social media, e poi un gruppo fantastico di produttori video che è Videodrome. Perché lo dico? Perché veramente, a parte la squadra mitica di MtMG Guru, però con la collaborazione, si parla tanto di co-creazione, cooperation, è veramente un e quindi MtMG Guru è così e risponde a queste spinte, c'è poco da fare. E però ringrazio anche i partner senza i quali effettivamente in questo mondo di personaggi internazionali che continuiamo ad alimentare, a invitare eccetera, non sarebbe possibile. Partner storici come la Fondazione Fiera di Milano, che ha aperto le porte all'innovazione anche nel suo mondo, Fastweb, Artemide, visto che oggi parleremo di materiali viventi, nuovi materiali con il suo tema della luce, è un'azienda estremamente innovativa. Poi abbiamo la Fondazione Cariplo, che ci garantisce il fatto che siamo attenti alle trasformazioni sociali, ci interessa capire in che società stiamo vivendo e che cosa possiamo fare ognuno di noi nel suo piccolo per il meglio. E infine la Regione Lombardia con la quale, intanto saluto Antonella Prete che è qui con noi, con la quale facciamo da 3 anni un premio Digital Award, Il coraggio di innovare, l'abbiamo intitolato così ben 3 anni fa, e che quest'anno è partito proprio ieri, potete andare in rete, ilcoraggioδιinnovare.it, e sono aperte le iscrizioni per tutti gli innovatori di design e moda, perché ci serve per capire qual è insomma, lo stato vitale di questo mondo, perché al di là dei grossi nomi, delle grandi firme, c'è un pullulare di iniziative, di idee. A noi ci interessa scoprire questo tessuto vivo, vitale, e quindi incoraggiarlo. Avrete avuto una cartolina, quindi sintonizzatevi anche su questa iniziativa che poi avrà il suo epilogo in novembre, quindi ci rivedremo e ne sentirete ancora parlare. E poi adesso io chiamerei qui Giovanni Crupi, perché la collaborazione number one per questa edizione, siamo in questa bellissima sede, col Museo Nazionale della Scienza e della Tecnologia. Giovanni.
Buonasera a tutti, rubo davvero pochi minuti per dirvi innanzitutto benvenuti al museo e ringraziare Maria Grazia per aver pensato di portare qui questo appuntamento. Per il museo è un grandissimo onore, una grande responsabilità accogliere la community di Media Guru, e allo stesso tempo noi come professionisti siamo sempre ispirati e amiamo confrontarci con questa community e con i guru che qui ci raccontano il loro lavoro. Ci sono noi condividiamo tantissimi valori con Media Guru e ci sono tante risonanze con il lavoro nello specifico di Lining Yao, i temi delle interfacce evolute, della scienza che connettono la scienza dei materiali con l'ingegneria biologica, con la digital fabrication, fanno parte anche del programma culturale di questo museo, che si esprime con esposizioni temporanee e permanenti, attività educative. L'altra risonanza è proprio anche sulle modalità con cui la conoscenza e l'innovazione vengono costruite, e quindi anche il lavoro sulla costruzione di competenze. E a questo proposito vi restituisco una frase che ho sentito un po' di giorni fa dal direttore scientifico, il direttore della ricerca di un importante centro di ricerca italiano, che diceva: nell'ambito della ricerca dell'intelligenza artificiale farà la differenza come nei prossimi anni verrà costruita la conoscenza, e quindi saranno le nuove generazioni, probabilmente appunto nei prossimi decenni, a lavorare in un ambiente di ricerca in cui si abbattono i muri tra le discipline e le culture. E questo modello di costruzione della conoscenza farà la differenza. E per noi, per questo museo che nasce sotto l'egida di Leonardo da Vinci e che ha provato sin dall'inizio a mettere in dialogo la cultura umanistica con la cultura tecnico-scientifica, è una grande ispirazione e un grande punto di lavoro. Per cui grazie, buona serata.
Grazie. Sì. Volevo ricordare che abbiamo un po' avviato, prego. Sì. Assolutamente, mi sembra un bellissimo pensiero, perfettamente coerente. Tanto avete capito, Media Guru si sposta, è nomade, va nei luoghi coerenti con i temi che deve affrontare insieme appunto agli ospiti e a tutti quanti noi. Dicevo, abbiamo lanciato un po' quest'anno un po' quest'idea anche dell'experience, quindi per qualcuno di voi, avrete avuto un po' informazioni, questa volta con il Museo della Scienza abbiamo aperto il cosiddetto tempo d'attesa, abbiamo dato la possibilità di sperimentare un laboratorio, no? Che in poco tempo penso che abbia dato a chi ha partecipato la possibilità di capire cosa vuol dire interagire con i materiali e lavorare. È questo?
Sì, le attività del museo sulla cultura digitale sono diverse, e quindi abbiamo proposto da un lato l'analisi di un'installazione che funziona con interfacce evolute, che si chiama PET 2.0, che vedete appena fuori da questo auditorium, e poi abbiamo costruito invece con una metodologia che si chiama Tinkering un laboratorio di light play, quindi come mettere insieme creatività, scienza e tecnologia utilizzando anche la luce.
Grazie per questa collaborazione, Giovanni. Bene, adesso grazie. È arrivata con noi Cristina Tajani, che invito a salire qui sul palco. Cristina Tajani, abbiamo parlato di innovazione, parleremo ancora di più, entreremo nel vivo di interfacce viventi, di innovazione di materiali, di scienza, arte, design con Lining Yao. Cristina Tajani è assessora alle politiche per il lavoro, sviluppo economico, università e ricerca del Comune di Milano. Mi sono dimenticata qualcosa, Cristina? No.
Commercio, università e ricerca era la volta scorsa.
Ah, quindi è commercio, scusate. Però lei è il nostro assessore dell'innovazione. Dovessi fare una sintesi, direi l'assessore in ogni settore, compreso il commercio, che comunque sta evolvendo anche quello, no? Quindi non può non avere a che fare anche quello col mondo. Quindi io chiederei a Cristina, visto che il tema di oggi sarà proprio quello dell'innovazione in vari settori, e in particolare quello che toccherà Lining va nella direzione di due industrie importanti, che sono la moda e il design, di cui tu ti sei occupata e ti stai ancora occupando. Prego.
Grazie, buonasera a tutti. Devo dire che ho ascoltato le parole di Giovanni Crupi per il museo e il Comune di Milano si trova nella stessa condizione di particolare sintonia con il progetto MtMG Guru. Non è la prima volta che ci troviamo insieme a presentare uno dei vostri guru, proprio perché c'è un'assonanza e una consonanza valoriale rispetto al progetto che voi portate avanti. Milano, come sapete, in questo momento è un po' l'epicentro dei processi innovativi per quanto riguarda il nostro paese ed è forse l'unica città italiana che è in grado di confrontarsi con i migliori benchmark europei e mondiali, in particolare nei settori che fanno parte della nostra tradizione culturale e produttiva, il fashion, il design, ma anche la manifattura. Prima Giovanni parlava appunto di digital manufacturing come una delle evoluzioni possibili per il nostro tessuto produttivo, cioè l'innesto delle nuove tecnologie del digitale su produzioni che affondano anche in una tradizione storica del nostro territorio. Questo vale sia per le produzioni manifatturiere, su cui noi in questo momento stiamo investendo particolarmente. Il Comune di Milano ha lanciato poche settimane fa un programma pluriennale sul tema della manifattura 4.0 con l'obiettivo di riportare in città produzioni anche di prodotto, diciamo, quindi non solo una città dei servizi ma anche una città dei prodotti con caratteristiche innovative. Quello che ascolteremo stasera ha molto a che fare con questo tema e lo stesso vale per altri settori tradizionalmente di punta del nostro territorio che stanno vivendo un'evoluzione importante e particolare anche grazie al cambiamento tecnologico, il design in primis, ma anche il fashion, anche la moda. Noi oggi testimoniamo e osserviamo e proviamo anche ad accompagnare una crescita di quelle aziende che hanno saputo innestare su tradizioni e produzioni, diciamo, tradizionali anche in ambito appunto del tessile, il cambiamento e l'innovazione tecnologica. Oggi anche aziende tradizionali del settore tessile hanno convertito le loro produzioni in direzione di, diciamo, tessuti ad alta tecnologia anche con scopo medicale in alcuni casi, e quindi è per noi molto ispirante l'idea e la possibilità di poter anche, diciamo, simbolicamente avere uno scambio di prospettive con la vostra ospite di questa sera e di trovare in questo momento l'avvio di un percorso, diciamo, di riflessione e di progettazione comune anche su queste tematiche. Quindi grazie ancora una volta per averci portato qui un'ispirazione.
Veramente grazie, hai dato proprio in là, in questo scenario che appunto è Milano, il nostro paese, ma in particolare Milano, grazie appunto a queste iniziative. Noi abbiamo invitato Lining Yao, adesso la inviterò a salire subito. Avete capito lo scenario, la nuova manifattura, i nuovi materiali, cioè ci dobbiamo fare i conti, qualsiasi settore. Poi stasera entreremo, abbiamo detto, in due aree particolarmente sensibili della nostra città, per il nostro paese e per il mondo, la moda e il design, la ricerca scientifica, l'arte e l'ingegneria. Lining Yao, ti prego di venire, due parole con Lining. Io l'ho conosciuta all'Inz qualche anno fa. Arriva dal... Prego, Lining, vieni. Lei è una ricercatrice del Media Lab di Boston, da cui è partita insieme al Tangible Media Group di Hiroshi Ishii, che è stato anche lui un altro dei nostri ospiti, un nostro guru. E Lining ha lavorato ad una ricerca veramente di frontiera. Adesso è professore e docente alla Human Computer Interaction a Carnegie Mellon University. La sua ricerca va avanti, ha già ricevuto numerosi premi, ha realizzato varie esposizioni, tra cui l'esposizione Radical Atoms con le sue opere all'Inz che ho visitato. E vedrete, lei, lascio la parola a lei perché entra in questo universo di grande cambiamento della manifattura, nell'intersezione tra ingegneria, biologia, quindi scienza, ma anche arte, anche design e tutto il tema dei nuovi materiali. Anzi, scusate, volevo anche ringraziare Material Connection che ha collaborato con noi anche per questa serata. Lining, a te la parola. Thank you very much. Prego, io mi tolgo la scena a Lining. Vai.
Thank you for the introduction. My name is Lining. As Maria perhaps introduced, I'm currently an assistant professor at Carnegie Mellon University. I actually feel very humbled to be invited on this stage because my lifelong dear mentor, Professor Hiroshi Ishii from MIT, was on this stage 2 years ago. And indeed, I just finished my PhD 2 months ago. And so most of the work I'm going to present today are actually from MIT. I just want to make that clear at the beginning. So yeah, that's where I did my PhD. It's at Tangible Media Group and over MIT. So this is where I grew up. It's Inner Mongolia in China. And as little kids, we used to go out to the forest and pick up mushrooms after the rain. But of course, at the same time, we will pick up the pine cones on the floor. And when the rain comes, it would wash the pine cone out on the floor. Those pine cones will be closed. If you had the experience of picking them up after rain. And after a little bit, if you put it on the balcony, it will open up. And in fact, if now you put it back in the water again, it will close up. So in a way, a little pine cone, a little humble pine cone is a nature-grown smart material because it transforms, it responds to water, open and close, and this transformation is reversible. And if you think about it, it's pretty brilliant because there's no electricity involved. When human beings want to make a motion, we use motors. And how you power motor? You use electricity. So at the same time you are making motion or generating behaviors, you are also consuming energy. But nature does it differently. Nature does it in a very sustainable way, but also at the same time makes smart materials. And indeed, it's not a patent of pinecone. A lot of natural organisms do the same thing. For example, our familiar seed pod. When they try to get rid of the beans, they will form a helix shape and kick the beans out. So it is again a natural transformation that happens when the leaves became dry. Or this is a desert plant. Desert plant seeds, actually. When the rain comes, the long tail will become a screwdriver and screw itself down into the desert. So in a way, nature is doing this transformation for its own survival and replication. And everybody perhaps here is familiar with fly traps. It's a magical plants. When flies come, it will quickly close up to capture the flies and then eat it. And all those transformation, again, back to my subject, is electronic free. And they are all smart materials. And it made us as interaction designers to think. On a daily basis, we use motors all the time to make things move, responsive, and interactive. But how can we learn from nature? How can we learn from nature to build sustainable and smart systems? And that really drives my research direction. We call it transforming materiality. The idea is how you can utilize natural energy stimuli to transform the material itself and make it do smart things. So with that in mind, we've been trying really hard to manipulate all kinds of physical properties and transform, hopefully in a useful way. We've been tried to manipulate the mechanical properties of materials, optical property, electrical property, and also biological properties of materials. And with those knowledge, we were able to build functional objects, for example, robots, self-wrapping phones, self-folding chairs, and self-wrapping shoes. And we are also able to create scenes you can only see perhaps in sci-fi movies. But the difference is everything here, we made it real. So now I'm in Milan, and my friends in Milan told me Italy is all about food and beauty. So I chose 2 projects here to share with you guys. And one is about food, and the other is about fashion. And I think we will have some fun together to talk about these 2 projects. So we start with the fashion project. It's called Biologic, and indeed it's a collaboration among many members from very different disciplines, and it was conducted under the supervisor Professor Hiroshi at Tangible Media Group. Let's play a very short video. So perhaps you can tell I'm going to talk about a smart garment. And it's a garment that's driven by bacteria. And yes, we're putting bacteria back on your body, although as children, you are educated to clean the bacteria from your body every day. And this bacteria actually have a special name. It's called Bacillus subtilis natto bacteria. It's actually indeed an ancient bacteria found from Japan. 1,000 years ago, on the quest to a battle, a samurai found the soybean held by a dry rice stalk made bag tasted better than the normal soybean. And later they found out it was because the bacteria hiding inside this dry rice stalk made the soybean taste much better. And Japanese called it natto bacteria. And since then, natto becomes a food. If you go to Tokyo today, natto food is still one kind of the most popular breakfast, indeed. And if you look at those little soybean under a microscope, you will see millions and trillions of those bacteria covering the soybean. That's the bacteria we used in this garment project. And indeed, these bacteria are edible. And you can imagine it's completely safe when you wear it. And we are just using this Asian bacteria in a very new way. We're using this bacteria as a nano actuator and also a nano sensor. So the bacteria is really tiny. It's about 1/10 of the diameter of a human hair. But we are able to somehow translate this tiny natural motion into a perceivable transformation on our garment. And the way we did it was to deposit a lot, trillions of those bacteria on top of a fabric. And all of the bacteria will work together and lift up the fabric up and down when the environmental humidity changes. And these are the complex patterns we are able to achieve. And you can see we can basically transform it in many different ways. We can make structures fold and unfold, or little gaps open up and close. And all these fabric, they respond to moisture. So it means when we change the relative humidity of the environment, the bacteria will change the size, and the size change of the bacteria will cause the folding and unfolding of the fabric on a bigger scale. And accidentally we found, this little piece of film is indeed very responsive to the micro-environmental change on our skin. As we sweat, or as there's a bit of temperature change on our skin, the material will respond. And we thought, okay, so the killer app will be something on body. That's the starting point when we started to develop the garment. And we looked for New Balance, which is a local sports company in the United States, and we looked for them to learn better how body sweat and also heat map distributed, and we want to combine this knowledge into our garment. As you can tell, the final garment we came up really matched the body heat and sweat map on humans' back, and we are trying to make the part part that sweats the most with the biggest flaps, and also the parts that heated up the most with the densest units. So everything, including aesthetic, can be scientifically designed. That's what we want to do. And when the user starts to sweat, you can see the little flaps open up on the back of the lady. And we think it's interesting from a design point of view because it opens up imagination of a new ecosystem. So if you think about it, there are millions and trillions of bacteria on your back. We are almost creating a new ecology between those living bacteria and also human being as another living identity. But at the same time, it's also a new ecosystem between a piece of skin on your body and the human skin itself. We believe clothes is not only for making you beautiful or making you warm. It can be part of your ecosystem to understand what you need. In this case, is to understand, are you cold? Are you warm? Do you want to sweat? Can I help you to get cool? In that way, we're building a relationship between the clothes you wear and also the human body's needs itself. So we started this project, or we started the preparation of this project, indeed from a wet lab. So this is a big bioreactor. We can culture bacteria from it, and one bacteria can turn into billions overnight. Imagine that you get free motors. You get free motors manufactured overnight, and the duplication rate is huge. So in a way, it's a really cheap technology, although it is a high tech. And we then put those bacteria inside an atomic force microscope, and you can see those bacteria can expand and shrink as we change the relative humidity in the environment. And we then try to concentrate it, and we load it on top of a 3D printer, started to accurately deposit those nano actuators on top of a fabric that we made beforehand. And you can see here we can basically deposit the bacteria to a very, very precise degree. So we can make each line as thin as less than 1 millimeter. That's the fundamental secret behind the very precise opening and closing when it comes to responsiveness to sweat. So yeah, we got really lucky to be able to collaborate with two amazing dancers over Boston Ballet Companies. They are actually all classic ballet dancers. They would dance Black Swan on stage for Boston audiences. It perhaps, I mean, I'm pretty sure it was their first time to dress up bacteria on their back. So at the beginning, we kind of have to educate them. Oh, you want to do this or that kind of posture to emphasize there are living beings on your back. But by the end, after a few rounds of photo shoot and video shoot, they started to create their own dance performances. The lady, Carolyn, said, actually, you know, now I felt it. If there are a lot of living beings on the back of me, then I should do this kind of expressiveness and this kind of posture, because I felt like I'm interacting with life. And that's the moment we realize it's not only that we rely on art to express our technology. Sometimes we can also inspire art expression. And from there, we were motivated to have a dance performance and we call it Dancing with Billions of Bacteria. That was the starting point of this curation for an exhibition. So for the Media Lab's 30th anniversary, we did this exhibition, and I had the idea of dividing the exhibition stage into the made and the born. So the idea is, if you think about it, we're using a living bacteria. However, we are using a 3D printer, which is a pretty mechanical device, to force the bacteria to self-assemble in a certain way. So it's really the spirit of the project is about the combination of the made world and also the born world. We want to show how the bacteria can behave if human interfere it, and also at the same time how the bacteria can behave if it grows naturally. And we put these two sculptures in the center, and it's really a symbol of the biohybrid. See, we made this body silhouette and also the substrate, a plastic substrate that are from the made world, but then we put the born world bacteria on top of the flaps. And please enjoy this short video. This is the made world. You can see they transform accurately, indeed exactly in the way we predicted in our software. And we know in which angle and in which speed it should transform. And this is the born world. And you can see they are beautiful, but they cannot be controlled as well. And they are organic. That's almost the tension we want to create in this project. That's the dancing with millions of bacteria part. They couldn't sweat. I mean, they were too nervous. So we put steam on the side to trigger the dancing of the bacteria. So the dancers were dancing in the steam, actually. Beyond garment, and people used to ask us, well, yes, you can make a garment, but it sounds like the bacteria is super powerful. What else you can make? The first idea we thought is to make life, to use life to remake life. So we printed those bacteria on top of fake leaves that are made of rubber, but we follow the veins of the natural leaf when we print those bacteria on it. And it turns out we can recreate life. The transformation, the transformed leaves really look at the real leaf when they are dry. And if we think about how nature are changing, we cannot interfere too much. Things become green in the summer and then they will die in the winter. But wouldn't it be cool if somehow designers have the superpower to be able to control the growth and dying of the life itself? So think about those little flowers. When we water them, they will blossom with both shape and also color. And indeed, this is powered by the bacteria. And now we are able to basically control the circle of life. And with that, we made a little cute application. So here you have a little tea leaf, and it was wrapped and seemingly died at the beginning. As you pour hot water, and as your tea is steeped, you can see the leaves will open up. It seems like the tea now starts to talk to you. It's saying, hey, I'm ready now, you can drink me. And we like the conversation, especially from a MIT Media Lab point of view. We love media, and we want to create new type of interface that can have a new type of conversation with the users and with the environment. And material is exactly one of the replacement we could think on top of on top of computer interfaces. And also, as I mentioned, bacteria is really cheap. It's a really cheap material, and we made hundreds of units with ease overnight, and we made a lampshade so the bacteria will respond to the light and modulate the shadow you can create out of a light bulb. And a toy company found us, American toy company. They were saying, oh, we love to put moving things in kids' toy, but for babies, it's very dangerous for them to swallow electronics. So we made this electronic-free robots, let's say. So by folding and unfolding a corner of a little book, you can make the paper robot dance. And you can think many more applications from there. And we are based in the East Coast of the US, and it's a boom there talking about biotech. So we were like, okay, so if we're there, we're using a living material, we're gonna have to do some DNA programming, we're gonna have to do some genetic modification. That's what we did. So for the project I just showed you, we basically got the natural bacteria. We didn't do anything we didn't do anything to modify the DNA, but we thought it would be cool. Now, if in order to make multifunction nanoactuator, we will use genetic modification. So, dear collaborator, Dr. Wen Wang, indeed genetically modified the bacteria. So now, as the bacteria become bigger and smaller, it also glow more intensively or less intensively. So now we got a multifunctional actuator, basically a response with it's both motion and also the color. And if we put it on a fabric, we will be able to get, again, a fabric that are responsive to sweat with the shape, but now also with the color. The application we can think of is, of course, related to fashion. That's a shoe. So now you can imagine if you run in dark and you were sweaty, the pores will open up, but at the same time, it will glow more and more intensively to give you some safety warning on the street. So this is when your sweat comes, all the bacteria will start to glow. And we think, although we only engineered the glowing function, but the direction basically opens up a huge potential of using genetic modification to redefine the function of living materials. So imagine we can also engineer the bacteria to generate some nice, friendly perfume smell when you are sweaty. And these are not sci-fi. These are totally possible. Biologists are using those technology to make smart pills for pharmaceutical industry anyway. And we are here as designers to encourage more biotech, but used in daily life. And the most recent update of the biologic project was the ongoing exhibition at Centre Pompidou, not far from here in Paris. And we made a back piece, the transform and also the glow in dark. It will there till June. So anyone go to Paris, you're welcome to go and see it. So yeah, that's the fashion project, and since I'm in Italy, I'm also super excited to bring the newest development in our team. That's a project related to food. And I co-led the project together with Dr. Wen Wang, my long-term collaborators forever. And again, it's over MIT where we developed it. And yes, it's a piece of pasta. Before I talk about the pasta, I'd like to mention why a group of graduate students from a super engineering school decided to work on the food project. And you can indeed get a PhD degree out of a food project. For all the projects we do, we have this strong belief that we can program physical material in a way that are impossible if we only work with computer. So in order to make a programmable material, basically smart material that can be adaptive and responsive, we need 3 key ingredients: the energy stimuli, the composition of the material, and also the properties we care. just to go back to the biologic project a little bit, we would think the stimuli is the relative humidity. So when you sweat, your sweat itself is the stimuli. And the composition means the way we design the structure with the 3D printer. And the property we care is the opening and closing of the flap, and also the modulation of the sweat behavior. So with this rule, indeed, you can design almost all kinds of smart materials, and a lot of programmable matter up to date are following those rules. Up at this point, our team thought we were the super atom hackers, and we were able to control the matter as how our Mother Nature can control the natural materials. But until we see this video. This is deep inside the mountains in the northwest of China. And these people, they understand the Hooke's law, which is a pretty classic material property expression, so well, so that they can make noodles as long as they want. Or this lady, she understands the thermal expansion so well, so she can make her bread as big as she wants. Or even my own dear grandma, she's able to tell when the dumplings are done, when they are floating on top of the water. There is a law of buoyancy behind it, and I learned how to cook dumplings from her. And as you can see, manipulating physical matter and also talking to the material by the change of the physical properties are not new, are not invented by graduate students from MIT or anywhere else. These are invented as an ancient wisdom. You can also tell kitchen and food, these are great subjects for us to think about smart matter and programmable material. Because in the kitchen, when we are cooking, boiling, frying, microwaving, we are constantly introducing all kinds of energy stimuli. And there are a lot of transformative properties we care. When we cook, we care how we communicate with food through their color, through their change. When you bake a bread, for example, just imagine. And also when we eat them, we care about the saltiness, the crunchiness, the stiffness of the material, the elasticity of the material. There's a holy grail of physical science in terms of food and cooking. And in claiming that, we would say there is a big design space if you think about kitchen. And we start to put programmable materials into the context of kitchen, and we call it functional variation food. And that's really the driven point for us to cook. And indeed, there are amazing designers who have been trying to manipulate the physical properties in food, in the kitchen. And food can respond in a very programmable way in their shape, in their color, under different stimuli such as temperature, pH, air pressure, etc. pH sounds scientific, but you know, vinegar, that's a very interesting pH trigger. And we listed down all the physical properties we would be interested in the kitchen. And you can count them: elasticity, swelling rate, hardness, etc. And of course, we first landed our eye on this familiar term, swelling rate. That's exactly the property we investigated in the bacteria for the biologic project. Why swelling rate is important or universe in kitchen? It's obvious. When you're cooking a pasta, your pasta becomes fatter as you cook for longer term. That's also perhaps why you can tell your pasta is done cooking. Science is super easy. Starch is one of the main components inside the flour, and you put it in water, it absorbs all the water molecules, and you can see an expansion of the matter itself. And the interesting part is, if you look at the behaviors of different edible material, they, to some extent, all swell, but they swell at different speed and at different rate. So for example, gelatin, which is a type of protein, swell very different from starch. And cellulose fiber, which gives us the crunchiness in food, they do not swell at all. So if you think about the idea of extract those individual components from flour and then recompose them in a way that's controllable, then we can control how matter will swell. So this is a piece of fake pasta. So imagine the light part being the protein, and then the darker brown part being the cellulose fiber, which do not swell. When you put this flat piece of pasta in water, you will get this bending behavior. So basically, it was flat at the beginning. As you cook them, it becomes a curved shape. And this is a microscope image of the diagram, a piece of real pasta. You can see the center part swell more slower than the sides. I'll play it again. You see it was quite interesting. See the center part, it grows slower. That's because we put cellulose that does not swell at all at the center. And with this principle, you can now manipulate all kinds of shapes. If you make flat disc, it can transform into a saddle shape, and you can make all sorts of saddles as well. And this is pretty much how potato chips work also, by the way. And you can make a flower. You can make a flower transformed from a flat disc. And here are more pastas. We call it transformative appetite, as you can imagine why. And we want to combine 3D printing to precisely control the composition of the pasta. And here is in the same wet lab, indeed, where we did our biologic experiment. We made a edible film. It was prepared wet, and when we waited it dry, and then we deposit the non-soluble cellulose fiber on top of this dried film. We also had an online interface where people can choose their favorite shapes and define or fine-tune the geometry they want. And these are real samples. When you cook those flat pieces in water, as you can see, they start to take on different 3D shapes. And these ones were kind of a time lapse of a transformation when you cook them in water. And we tried really hard to make some of the shapes look like the traditional pasta shape, the classic shapes, but also make others look like alien, more strange, because we want to show with this new self-folding technique, we'll be able to produce shapes that are hard or impossible with the traditional pasta making techniques. And if you're a chef, you want to test out how your food are, you would eat them. If you're an engineer, if you want to know how your food tastes like, you go to the lab and test out the property with the machine. That's what we did. We had a pasta cutter that has precise sensor on it, and we were able to test out different physical properties of different shapes of pasta. So hardness test, firmness, and springiness test. This is a fracture test. We want to test out how easy our pasta break, and also the elasticity test. And these are all related scientifically to the texture and mouthfeel when you eat them. And the ultimate goal was to prove different shapes can be associated with different sensations when you eat them. I guess I don't need to educate this crowd because you guys are the ones who claim different shapes have to be associated with different sauce, and you will make fun of people outside of the country who chose the wrong pasta. And we are only scratching the surface. I'm actually looking for feedbacks on this part. And we also want to get feedback from experts. So we started to work with a chef. So Matthew is an executive chef in a high-end French cuisine restaurant over Boston. And he gave us a lot of feedback in terms of how to manipulate the flavor of those pasta. You can see here we made some flour pasta, helix-shaped pasta, and also saddle pasta, all from flat disc. This is a squid ink. This is plankton seafood pasta. And then we also got another one that's mushroom paired with the tomato. They are all called salad noodle. This is our favorite, by the way. So you got all the transparent flat film, and once you put it in a soup of caviar, it will wrap all the caviar around it and form a little cannoli. We call it caviar cannoli, and this process happens within seconds. And then the chef literally on site told us, "Oh, I'm gonna serve this in front of the customer. Can we do it? Can MIT allow us to do it?" So that was pretty fun. And this last one, it's a smart noodle programmed by the way you cook it. So it's long when you cook it in colder water for shorter time, but then it'll self-chop itself into smaller pieces as you cook it for longer term. It also wraps into what's that called, macaroni? Yes. So the idea is you can cook longer pasta for yourself for the right texture, but also to cook longer time for your children to get a easy digestible pasta that's in a shorter range. See here, you see again, we are utilizing the idea of an interaction designer. We want to program food, and we want to program food to interact in the way that are smart. And for example, you can use water now to program a physical matter to get the right needs you want. And my dear friend Wen Wang, she did this calculation. Very geeky, scientific. The idea is if you calculate the space of short macaroni pasta will take compared to the same amount of macaroni but made from our flat pasta initially, apparently we can save 67.3% of shipping and packaging space. So basically you can save a lot of cost, shipping and packaging cost, by making things flat initially, but only achieve the 3D shape when you cook them. This is very important. That's why IKEA make all the flat furniture and then bother you guys to assemble them. And of course, we also care about the legacy behind shapes. That's why we tried so hard to make different shapes. And when we eat a piece of pasta, it's associated with the culture, the identity, and shapes are associated with our feelings and also our flavors. And with our technique, we're able to make 2D shapes, 3D shapes, 2D printing geometry that transform into 3D shapes. Anyway, there's a whole grammar I can talk about for another hour, and it's also a piece of science by itself, basically how to manipulate and simulate the shapes computationally. And we thought the possible ways we can disseminate our ideas, and of course, supermarkets. Indeed, I just took this amazing chance of going to Milan to visit Barilla 2 days ago in their headquarters, because we were interested in seeing how the pasta producers and also large supermarkets such as Target perceive this being actually sold in their market. And this is one of our next big step. And we also cares about the idea of democratizing food. That's why we started to build an online interface. Imagine your daughter for her birthday party can go online, customize the right flavor, right color, right shapes she wants, and claim this is the pasta she made. And she can also invite her friends to learn the science behind how a soft matter can respond to water and transform into mathematically simulatable geometry. And we also cares about this food being served in high-end restaurant, because ultimately we are designers and we care about the experience. But the French chef who worked with us actually gave us a lot of hope, serving self-folding cannoli in front of their customer within seconds. And I also talk about saving shipping and packaging costs. And there were mountain hikers approached us saying, oh, great, so now we can just carry a little bag but cooking our favorite pasta. But also for disaster sites, that's a bigger issue. We can assemble and ship flat things to save the time and cost, but deliver nice and also enjoyable food for the local people. And the last one, almost the most exciting one, was support for the space traveler. If you talk about 2 or 3 years traveling to Mars, you want to bring some food. You want to bring some food not only make you full, but also make you happy and enjoyable. And I guess everybody here agree with me, pasta is one kind. And we're gonna have to convince NASA and also European Space Research Center that flatly packed nice pasta is one type of the thing that should go into the space. And we tried really hard to disseminate our vision. So we run also a lot of courses and workshops around so far the US. And this was a course we run over MIT. None of them who were wearing chef clothes were chef, including me. I'm not so good at cooking, but we just decided fake it until we make it. For the sake of science, we decided to cook. So that was a very interesting experience. And indeed, back in 1945, MIT built its own first food science department. However, it got terminated in 1988. I don't know why. Maybe cancer became more an emerging issue than making people full back then. But we were super, super glad to see now pasta becomes a trend, food becomes a scientific trend again. So this was in May 24th, 2017, 2 weeks ago. Our pasta project was on MIT News front page, and there were a lot of media attention, but this one was the one the team mostly proud of because it indicates food as a subject is not only a subject that farmers do or food producers do. Food can be a subject for scientists to investigate, for mathematicians and physicists to look into, and for interaction designers and also perhaps fashion designers to investigate. We were very encouraged by that. And this is an interesting anecdote. So on the left hand, on the right hand, this side, that's me and also my dear Professor Hiroshi Ishii over MIT. And you can see we work in scientific labs and we were pretty isolated. Usually we were not educated too much of associating us with real life. We wanted to be there so we can think about the future. And on this side, that's me and my mom, and she is all the way over in Mongolia, didn't even have a high school degree. So it was kind of hard for me to communicate what I did over MIT to my mom all the time through the past 7 years. But then recently I told her, hey mom, I've been working on a project and I think I can make you self-folding dumplings. That was the first moment when my mom started to laugh and heard what I'm talking about. So I think food is an interesting subject for us because it built a bridge between a MIT professor and also a lady over in Mongolia who didn't have a high school degree. And I also think it's just a universal topic. If we are able to contribute to people's daily life, young people, old people, Chinese people, American people, awesome. So that's why we pick up food also as our context to explore programmable materials. And by the end of the talk, I'd like to share a little bit of the design philosophy behind all the projects we do. We talk about interdisciplinary research a lot, or interdisciplinary way of doing innovation, let's say. But we know, I guess if there are designers, we all know we talk the most in terms of combining engineering with design, but less about science and design. It's very natural for us to think about, so design has to be technical now, so we have to integrate Arduino board, which is an electronic board invented in Italy. Thank you. But also it's easy for us to think about art can be combined with science. Yes, we use math to design art, like what Asher did. It's easy to understand, but it's less normal for us to think all those 4 components as a holistic picture. And here, exactly. So design talk less about science, but more of engineering. But then the real holistic picture, I think would be the real combination of the 4 disciplines all together. So think about the 2 projects we just talked about. Without the scientific curiosity of looking into nature, understanding the mechanism of how pinecone works, how your starch works in water, or how a bacteria expand and shrink in water, we will not be able to even start both projects. And of course, design, as a designer, I would claim it's also very, very important in this whole picture. I think design as a subject
give us a warm heart. We start to understand we want to create for a context, for a usage, and for the benefit of humankind. That's why when we design the garment, we don't do it for aesthetic only. We want to really understand the needs of the human body and then design for it. And we tested the garment really hard in a gym. I personally wear it and just wanted to see if it's functional or not. When the moment I feel the little stream of cold air traveling through my body as I'm sweating, as my garment is transforming on the back, I felt that's the right research we should do. And engineering is almost a hidden hero behind our projects. When media comes, reporter comes, they talk about, wow, what you did, it's so beautiful, but they never talk about how hard it is to make those and why you make those machines to do that. But indeed, to reach the accuracy that we want to achieve, we had to do a lot of engineering work, and those were tedious and those were boring, but those were super important. That's, I guess, behind any successful project, and in engineering school especially. And for the art part, we didn't forget art. That's why we had the great honor to work with amazing artists from different fields, from the fashion designer who designed the garment itself, to Matthew as a chef, to amazing Patrick, who was the ballet dancer from Boston Ballet Company. Collaborating with them really gave us a lot of inspiration, but also the faith that science and engineering can make them excited, can inspire them, can also be inspired by them. And I'm super excited to be a designer because I think designers are among the most sensitive ones for each and every age. We smell the trend of the technology, and also we smell the trends of human needs. And if you think about from the very, very old ancient days, designers had been playing a role. And just in terms of what we wear, when linen comes, we design linen clothes, and then now we know better how to interact with life, and we started to make silk clothes. And today, 3D printer comes, and we thought, oh, we're gonna 3D print clothes. So designers are always there to frame how our life should be, and also how our humankind should move on. And through the evolution of design, we also see the trend from the transition of the born to the trend of the transition to the trend of the made. So it's an evolution of materials we are talking about through the design, and it's also evolution of manufacturing. But in our own experience, we thought the future of clothes can never be 3D printed only. Usually, you have to, of course, put your heart, put your intelligence, put your understanding of the design and human needs, but also put the combination or the hybrid of artificial and natural materials. If you think about the garment again, it's a piece of bacteria, but being deposited on top of a silicone, fabric, or plastic, and we are constantly combining the best of the both worlds, the responsiveness of the natural world, and also the sustainability of the natural world. On the other side, the accuracy and the controllability of the artificial world, and again, it's also a combination of the artificial and natural processes. I talk about 3D printing, that's an artificial process. But we also talk about growing bacteria in a wet lab, that's a natural processes. Again, each has pros and cons. We just have to mediate ourselves and constantly pushing the boundary and redefine ourselves, and also redefine the tools, the materials we are using. And it's, again, not new. It's not claimed by us. It was claimed by the ancient wisdom. If you think about how our silk cloth made, they were started from a natural process. We get the leaves, we grow the silkworm, or we culture the silkworm, and then we also harvested the silk. These were all natural processes. And then we invent our weaving, knitting machines. We start to manipulate the silk. And by the end, we get this piece of silk fabric, this humble silk fabric. That's a hybrid of both worlds. That's what we are talking about. But the only difference, I guess, is that we are giving a bit of a modern twist of this ancient idea. So that's the key message I'd like to convey today. So let's imagine a world that's not the born, not the made, but indeed a hybrid of both. And thank you very much. I have a little earphone, so anybody speaking Italian, I'm happy to understand your questions or
sì, siamo qua per... Ci sono domande? Beh, io non so come ringraziare Lining per averci mandato questo messaggio così forte. Spingiamo avanti l'immaginazione, i confini, eccetera. Ci sono domande? Ci siamo dilungati un po' tanto stasera, ma penso che questa carrellata sia stata... Beh, ci lasci veramente qualche suggestione, qualche punto di riflessione in più. Prima di dire qualcosa io volevo sentire voi però. C'è qualche intervento, domanda? Avanti.
Only a nice young lady like you can come to Milan and challenge a couple of the most important taboos on which our culture is based, fashion and food. Now, I was thinking just a couple of questions. The first one is, how did Barilla reacted to your presentation? Okay. And the second is more radical. If your mama is so good in folding raviolis, jiaozi, why should you suggest some bacteria do the same thing?
Thank you for the question. So about the first, I'm not sure if it's business confidential, but since Barilla is supposed to be your amazing friends, I will just say it. I was invited to visit the 3D printing division of Barilla. Anyway, they do innovative pasta development. I'm pretty sure not in the market yet. Yeah, so they were super interested in the process we are using because in a way, it's not 3D printing anymore, it's 4D. Because you print and then, but as time goes, you transform it again. And we also, compared to the 3D printing, which is kind of slow process and expensive process, our stuff, although it's 4D, but you process everything, if you notice, in flat sheets. So you prepare flat sheets, and that's a very standard process, not only in food, but also in our fabric cloth industry. And it's much cheaper. So they bought that point, and they also really agree in terms of how geometry can provide different interesting experiences. So we were, I mean, nothing really settled. I was only there for 2 hours, but we are now in serious conversation to bring it further. And I also just believe, you know, if you work on a pasta project, you're gonna go to the home of pasta. And if people here like it, oh yeah, we're gonna have to be able to sell it to American and elsewhere with the help of Target and other supermarkets. So in terms of the second question, I started to think about self-folding dumplings because maybe like pastas here, dumpling is a big thing, a big tradition in China. The difference is people don't make it every day because it's a super tedious and time-consuming process. You prepare everything from scratch. You fold and you fold. So it's like sequential work you have to do just to make one dumpling. And I remember every time I go home, because all the way states from China's big journey, my mom would spend her energy, the entire energy and her entire time when I was there to just prepare the food, to welcome me and then to say goodbye to me. I felt, and that was not only now but also back when I was a child, it was always in my memory. It's an enjoyment, but especially for women in the family, it's also a service. So I thought with the technique, if we can save some time for them and effort, so I get to spend more time with my mom to have interesting conversation, that would be great. But of course, I also believe another thing about design is to create the options and diversity. It's not everything we create. I guess even from MIT or Carnegie Mellon, where I'm gonna join, are all good. So we are trying so hard to provide all the options technically and artistically to the people, and so that you get to choose. And I think this is just adding one type of diversity to the legacy of food.
Ancora una domanda? Prego. Ecco.
Hi. Thank you very much for your speech. It was really interesting and also inspiring for me. I'm working in fashion, so thank you so much, because I really feel you're passionate about your work, and I love it. Working on fashion, I'm very curious about the garment you talked about, and about, is there any limit in duration? And another one was that you talk also about the sensation, so the feeling to have something on your skin. So two questions in reality. The first one about duration and limit, and the second one about the feeling. Thank you.
Thank you for the question, and it's a very common question I will be asked by a lot of people, especially from the sports field. There will be American Cup or similar type of teams approaching us and say, "Oh, is it ready? Maybe in Olympics we can use it," but not really. That's part of the scientific study. We spend a lot of our time to test out the possibility, but it's still a bit distant from actually pushing this product to the market. So indeed, for example, being machine washable is a big problem for us now, because we haven't done any chemical modification on the surface of the bacteria, so it's only physically attached to the fabric. And there are a lot of other issues as well. For example, it might be the good season to wear it in the autumn, but not in the summer, and there are a lot of science behind it, and I can talk about in detail. And the second question, how does it feel? I think this would be a very good question for the dancers. For me, I wear it several times until we had to switch to professional runners for the gym test. But as I mentioned, so first you don't feel much difference before running, before the things open up. It's just a piece of fabric, flexible flaps that were made of sports fabric anyway. But once you start to run, you feel like there are little holes opens up, and then the cold air traveling through, and that was a magical moment. I guess it's also fun to see people standing beside you and staring at you, be like, "Ooh, what's going on?"
Abbiamo mandato ovviamente questo talk in streaming. So che ci sono delle domande dalla rete, visto che ci sono molti interventi.
Sì.
Prego.
Sì, Maria Grazia, abbiamo delle domande dalla rete. Se vuoi dire a Lining di mettersi le cuffie così sente direttamente la traduzione. Si tratta di un quesito a proposito dell'etica, perché si parla tanto di roboetica, delle questioni relative all'interazione dell'uomo con le macchine, ma cosa succede se si verifica un'interazione tra la biologia e la tecnologia così avanzata? Quali sono i rischi che Lining vede da questa sintesi tra biologia e tecnologia?
Thank you for the question. It's about the risk between biology and technology. And again, being in the East Coast biotech hub of the US, we heard of the discussion related to biotech and ethics a lot. And so far, I think at least our approach of perceiving materials, perceiving biology as materials, and trying to combine that with artificial materials and machines are still not so much touching the ethic point. So first, we are very interested in plants. So a lot of, as you can see, a lot of my slides is about how a pine cone is doing the work, and how fly traps are doing, and trying to understand them, and also trying to integrate them into the artificial materials. But less about animals. I do believe once you get into the field of animals, you feel the life at least more. And another point is, I don't know. I think we also didn't do much with the bacteria. So the bacteria actually, anyway, they grow in that manner. So they replicate, they find nutrition resources, and we are now just putting it on fabric. We didn't even kill them. By the way, they are still alive on the fabric. Yeah, they feel very happy when the sweat comes, and then they relax a little bit with their muscles with quotation, and of course they turn into a zombie mode because there are no nutritions on the fabric. But if you give it nutrition again, the bacteria can become alive again. So in that sense, it's less of an ethic problem. I do know a lot of projects has more ethic problem. We can talk about it.
Grande tema questo dell'etica e il rapporto nell'era digitale, il rapporto con le tecnologie. C'è qualche altra domanda? Non si vede bene, scusate, se c'è qualcuno che alza la mano. Eccone uno, prego. Aspetti un secondo il microfono che stiamo registrando tutto.
What happens if you don't use your shirt and you don't sweat and you put it in the cupboard? The bacteria die and you pick it up maybe a month later and nothing happens?
I have to clarify. So actually the expansion and contraction of the bacteria is not a living activity. So it's a mechanical performance of the material itself. As I explained, it's the protein, the sugar, and the DNA components absorbing water, swell, and desorbing. It's a physics phenomenon, not metabolism-based phenomenon. So in that sense, the motion of the fabric has nothing to do with the bacteria being alive or die. However, the bacteria do not die. So the specific type of bacteria we use, natto Bacillus subtilis, they turn into a zombie mode when the nutrition is constrained. So it's called endospore mode. Basically means it doesn't replicate, it doesn't need nutrition when the environmental conditions are constrained, but they keep their possibility of becoming alive again. Yeah, so indeed there's a science paper talk about how we retrieve life from millions of years ago, Bacillus subtilis.
Thank you.
Bene, se non ci sono altre domande, ma so che poi appena rompiamo le righe subito, io volevo intanto ringraziare veramente Lining per questo suo talk, veramente quello che mi ha colpito, veramente merita questa sua... Posso dire la leggerezza con la quale affronta, leggerezza nel senso di leggerezza dello spirito con cui affronta degli argomenti così complicati, il modo in cui ce l'ha anche raccontati, che trasmettono una grande passione. La ringrazio per averci tracciato uno scenario che dovremmo noi guristi, media guristi, tenere presente. Poi so che ci sono fior di professionisti qui del mondo della moda, del design, eccetera, tenere presente, perché nello scenario che stiamo cercando di monitorare, di esplorare con questi nostri appuntamenti, il tema delle interfacce, il tema della relazione con gli oggetti, il tema della cosiddetta appunto interazione, rapporto uomo-macchina, e oggi possiamo vedere con Lining parlare di relazione uomo-materiali, questi materiali viventi, eccetera. È uno scenario molto interessante, perché se noi pensiamo, chiudiamo gli occhi, pensiamo a quello che mi ho sentito raccontare anche solo a proposito dell'Internet of Things, di come entreremo in relazione, il fatto di pensare, come ci ha insegnato Lining e anche Roshi Ishii, che c'è una relazione profonda tra mondo reale e mondo virtuale, quindi di come è possibile programmare i materiali. Lo trovo estremamente interessante. Quando lei parlava di nano attuatori, quando Lining parla appunto di programmare i materiali fisici, quando ha lanciato, io non sono un'esperta di moda, ma quando ha lanciato questo tema della che appunto la moda è forma, è creatività, ma in questa maniera si pone molto l'accento anche su quella che è una parte, diciamo, funzionale della moda. Insomma, sono dei temi estremamente interessanti che ci fanno capire come dei settori che noi conosciamo, sappiamo che sono importanti, soprattutto nel nostro paese, per la nostra economia, eccetera, abbiano veramente sia importante che si incrocino col tema dell'innovazione e che vengano viste varie prospettive, assumendo, e questa la ringrazio veramente tanto, il suo punto di vista, che è quello di tenere viva la curiosità o l'osservazione. E l'altra cosa che a me personalmente è piaciuta e che consegno, diciamo, come un pensiero per MtMG è la metodologia, per cui l'interdisciplinarità famosa, ma dove l'arte e il lavoro insieme a ingegneri, insieme a design, il ruolo del design è così fondamentale. Insomma, è un metodo che poi dà dei risultati con questa freschezza che ci fa intuire e capire che ci possono essere degli scenari interessanti anche per una sostenibilità economica, per uno sviluppo economico e professionale diverso. Quindi vi ringrazio tantissimo ancora una volta Lining, perché intanto io ci tengo a dire che tutti questi nostri ospiti vengono a titolo volontario e quindi veramente siamo felici di averla ospitati noi per primi di MtMG a Milano, nonché in Italia, e vi diamo appuntamento per un prossimo MtMG il 22 giugno con Curtis, che ci parlerà di intelligenza artificiale e comunicazione, come cambia la comunicazione nell'era della intelligenza artificiale, artificial intelligence, nell'auditorium Testori della regione Lombardia. Quindi ci sposteremo e affronteremo un altro aspetto del cambiamento che stiamo vivendo nell'era del digitale. Grazie tante per la vostra attenzione, seguiteci sui social e soprattutto sul sito. Grazie mille. Grazie.